Welcome back to the Gum series. This is the fifth video. I want to go more in depth on code generation and using Gum in Monogame. I'm going to go fast, so use the chapters, pause, and rewind. First, I'm going to show you an example live in Monogame. Then we'll dive into the Gum tool as well, where I'll explain 6 topics. Some of those topics are covered at a high level in video 4, but we'll dive in again for this video. And those are things like creating screens, using a font, enabling code generation, load a Gum project into your game, swapping between 2 different screens in the UI, modifying objects at runtime. So let's start with a demo. This is the main thing I want to go over is this realistic project example in Monogame. I've created a simple 2-screen user interface based off of Super Mario Bros. From the Nintendo Entertainment System, the NES, using the FlatRedBall guy image instead and a generic pixelated font. So here is the stage intro screen, and when I press enter, we can see that we've now got the fake simulated game screen. And really the part of this that I want you to focus on is up top here. This is the user interface aspect that was built in Gum. We've got these different elements that are placed specifically on the screen in certain locations, and I can press the P key to increase the number of points, and that will update the actual user interface. I can press the C key to simulate getting coins. We can see that just like in Mario, the timer is counting down for us as well. Now I want to give you an overview of the Gum project that was used to create this. There are 2 screens, the game screen HUD and the stage intro screen. I created these by simply right-clicking on the screens and add screen. Inside game screen HUD, I have 2 containers, a background container just to contain this background image, and then a container that's supposed to be containing all of the different HUD elements. So we have the points, the coins, the world, and the time. By having each of these in a container, it makes it easy to spread this out evenly across the top horizontally. To do this, under Children Layout, I'm setting the value to Auto Grid Horizontal, and then the Auto Grid Horizontal cells defaults to 4, which we needed, and I just changed the bottom one to 1 because we don't want multiple different rows in our data. You can see that the width for this primary container is set to 100% of the parent. This makes sure that it is containing the entire size of whatever the parent is. And because the parent is a screen, it's the entire width. The height, on the other hand, is set to 0, and we're setting it to relative to children, meaning that the height will adjust based off the height of the children inside of this parent container, which is the height of these 4 containers. Each child container is set up so that the same attributes or variables are set for pretty much all of them. The X units are set to pixels from center. The Y units are set to pixels from bottom. The X origin is set to center. The Y origin is set to bottom. Width units is set to relative to children. Again, so the container can grow based off of the contents. The height is also set to relative to children, so it can grow based off the contents. And then down below, for the 3 of the 4, we have the children layout set to auto grid vertical this time, and we have 1 horizontal and 2 vertical. The difference would be for the coin, where I'm using, instead of grid, I'm using left to right stacking. There's a spacing between them of 4 pixels. This makes it so that each one of these 4 containers has the elements inside of it and will auto size itself correctly based off that. But then there's these 4 individual elements that get split evenly across the screen based off that parent. Another aspect of Gum is that you can use different fonts. You don't have to use the same font that comes with Gum or that is default. If we look at the text object, we can see that I've set this equal to a specific font called Press Start 2P. Now, I could have had any other font here, and if you want to use a font, you can download fonts from the internet, make sure it's from a reputable site, and then you just have to right-click on the font and install it in Windows. You may or may not have to close Gum and reopen it, and then you should be able to select the font that you want to display right here in the GUI. And then it will change what that font looks like just by you changing the font here. Don't mark Use Custom Font because that's a completely different thing and maybe an item for a future topic video. What you'll also notice is that I've actually modified the standard element. Now normally you wouldn't modify these. You would put them into either a component or into your screen as an instance, and then you would modify that instance. So these are instances right here of a text standard element. However, in this situation, because all of the fonts needed to be the same size and the same font type, I changed them on the standard element to make things a little bit easier. It's okay to do that if you understand what you're changing and that that's going to impact your entire project going forward. Obviously, you can still change the font here inside the instance, but now I don't have to mess with it. It's defaulted to 16, you can tell by the green, and this font is defaulted to Press Start to Player, again because of the text standard element, I've changed the values here. I'm going to expand these out so you can take a look. They're all basically the same. They just have a label, and then they have a value or an item that can contain the actual value you're going to display on the screen. The difference is the coin, which that has a sprite and then two text instances. The stage intro is essentially the same, so I won't go over that. You can check out the code on GitHub. I'll be posting a link to that so you can download this project just to take a look at how I set everything up. The next piece here I want to go over is code generation. To make sure that this will actually end up in the project, what I have to do is I have to change the output library to Monogame. Object instantiation type, I recommend using find by name. And the last bit is that you need to specify where this code will be generated to, where these class files will be created and placed. And so you want to put this at the project root, so the place where your .cs proj file is located. And for me, that is right here in this folder. Once you do that, you just need to hit generate code. It will tell you that it generated game screen HUD runtime.generated.cs. I've opened up the folder so we can take a look inside, and we can see that in this root folder here, there is a folder called screens because we've got those two screens. Inside, we can see that there's that stage intro runtime.generated, game screen HUD runtime.generated, but it will also generate two other files. These other two files that don't have the .generated, that's where you put any of your custom code. Don't put custom code into the generated files because whenever you make a change in the GUM tool, it will automatically generate new code and overwrite your changes to these two files. So don't modify the generated files. Now I want to give you an overview of the GUM code in Monogame specifically. So like the previous video, the first thing you have to do is you have to make sure that you add the NuGet package. I have it already added, but you just browse for Monogame, gum.monogame, and you would add that. Looks like there's even an update out here, so I would click this, click update, and now it's going to get that newer version of the code, the NuGet package. The second step would have been actually going into the GUM tool, creating the base project and saving it to the subfolder underneath the content. So if I go here, we can see it's got this GUM project. I saved it right here because it will create all of these folders and files inside of there. And so you want to make sure that it's in a subfolder in your content so that it all stays together and doesn't get polluted with your other content. The next step is to remember to set the output of these files here to copy if newer. And we showed a trick in the previous video where you can actually open up your project and you can change this so that it says basically all files and folders, go ahead and copy them if they're newer, basically. So this is a little trick to do that. Taking a look at the game1.cs file, you can see I added a graphical UI element called root. This will allow us to easily change the screen that is being drawn. Down in the initialize method, first we load the GUM project with monogamegum.gumservice.default.initialize. We'll pass in the graphics device and then pass in the project, our GUM project, relative to the content folder. Like I said, I've got mine in the content folder in a folder called GUM project, and so it's gumproject.gumx. And so I have to specify the folder name, then the file name. Next, we create the state intro graphical UI element, which is stored in the root variable. So we're looking up the intro screen, and then we're converting that into a graphical UI element, and we're setting that equal to the root, so that when we start the game, it shows the stage intro screen. During the update method, we do two different things. First, we call the global update right here for GUM's Monogame. This will do all of the small updates that happen in the background, but technically for us, this isn't really doing anything because we haven't defined any behavior or functionality inside of GUM that needs to be updated in this mechanism yet. Then we call update on the root using an interface. This interface is defined on both screens, and this is where we put our logic for the key presses in the screens. This way the logic belongs in the screen instead of polluting this game1.cs file with a whole bunch of checks for which keys are being pressed based off which screen and which situation. Finally, in the draw, we call GUM's draw method. Here we can see the very rudimentary or basic interface just to add a shared method called update to both of those classes, and this is using what's called polymorphism. As stated before, these generated files, stage intro runtime.generated and the game screen HUD or runtime.generated, we don't want to modify these because they're going to be overwritten whenever we make a change in the GUM tool. That's why they're made as partial classes, so that the combination of this game screen generated and this game screen that's not generated, which is also a partial class, these two can combine together at compile time to make a single class. Taking a look at the stage intro runtime, we can see that it implements the iMonogame GUM screen interface. This allows this update method to be called on either version of this screen without us needing to modify core GUM functionality. Because currently, GUM does not expose an update method that we can modify for these screens. We had to do that ourselves through this interface. In the update method here, I haven't really done much. All I'm really doing is trying to prevent the screen from jumping back and forth too fast when I press the enter key. So I've added a delay that will not allow any updates if it's not during that time. And the second thing is that when you press enter, it's going to do three things. First, it's going to clear the old screen by calling game1.root. That's the root that would be whenever the current screen is displayed, removed from managers. That way it doesn't get updated and drawn anymore. Next, we're going to find the other screen. So in this case, because we're in the stage intro screen, we need to find the game screen HUD. We're going to get access to that data. And then we're going to use that to create the graphical UI element and place that into the root. So we're basically switching out the screens at this point. Jumping over to the game screen HUD, we can see that it's also implementing the iMonogame gum screen interface. Again, the purpose for this is just to give us a method update that can be on either of these screens, and we can use polymorphism over here in game 1 to convert the root from the actual class it is, which is that bindable, what is it called, the gum.wireframe.bindable goo. And instead, we can tell it to convert it to an iMonogame gum screen that has a method called update. And so this isn't really a C# class, and so if you really have questions about polymorphism, object-oriented programming, or C#, I encourage you to look up other videos online. Inside the update method, I'm doing a few different things. Essentially, I have to update the time, and I'm updating the time here. On the NES, the time units were calculated as 1 time unit every 24 frames, and so that basically works out to just about 3 time ticks per second. So it counts faster than 1 second, essentially. And this is kind of where I'm trying to show you that you can modify the objects at runtime. So I'm changing the text that's being displayed for the time number text instance. I'm changing that at runtime by setting it equal to the value I'm calculating above. As with before, we have the delay, so we're not jumping back and forth between the two screens too fast. Then we're checking to see if it's enter. We're doing those same 3 steps. I just didn't notate them here with comments. And the last 2 pieces that are different between the screens is that I'm checking to see if the C key is pressed, which this is simulating maybe your character gaining a coin somehow. And then this is the P key being pressed, which is simulating points being obtained. And all I'm doing is keeping track of that in my own variable. So in this case, total coins is an integer, total points is an integer. I'm modifying those, and then I'm converting them to a string, storing them into the text instance. So that's all you have to do to get gum in Monogame in detail, showing you the different aspects, showing you how to modify objects at runtime, how to generate the code, get it into Monogame in a working example. Thank you for watching. For the next video, I'd like to get your input. Please add a comment below. Choose the next video between either me talking about behaviors in gum, animations in gum, or strongly typed components. If there are no votes or suggestions, I'll just go in order and I'll do behaviors next. Thanks again. Have a good one.